Welcome to lesson 38 of Algebraic Concepts, Equations, Repeating Decimals as Rational Numbers. So we're going to do a little something different today. Okay, here's our objective, our vocabulary, our rules and notes. Okay, so what we're going to want to do with this problem is write this as a fraction. So in order to write this as a fraction, and we're not talking about 7 over 10. We have the repeating 7. So let me be clear. So this is not 7 over 10. If it didn't have a bar over it, if it wasn't 7 repeating, we would know that that would be 7 over 10. So what we're going to do is let x equal 0.7 repeating. And then we're going to multiply by the place value. So we're going to multiply both sides, 7/10. We're going to multiply by 10 on both sides. So you get 10x equals 7.7 repeating. All right, so we didn't change anything. We multiplied by the same thing on both sides. Now what we're going to do is subtract out our first equation to get rid of our 7 repeating. And you have 9x equals 7. And we know to get rid of the number, we have to divide both sides by 9. So x equals 7 out of 9. And this is how you make a repeating fraction. So if you want to check it, if you do 7 divided by 9, you will get 0.7 repeating. Okay, so let's look at our next example. We have 0.35 repeating, where this is 0.353535 ... The whole 35 repeats. So again, the same thing. Look at the place value. So let x equal the repeating portion. Now this time the 5 is in the hundredths place, so we're going to multiply everything by 100, and we get 100x equals 35.35 repeating. Now we're going to subtract out 1x to get rid of the repeating portion. And you have 99x equals 35. And then we divide both sides by 99. And x equals 35 over 99. Okay, so now that we looked at every two problems where everything repeats, let's look at a problem where only one of the numbers repeats, like 24 thousandths, but only the 4 is repeating. So if we were to write this decimal out, it would be 0.24444 ... Well, the same thing applies. What we're going to do is make x equals negative 0.024, with only the 4 is repeating here. So we're going to multiply by everything that is not repeating. So tenths, hundredths, we're going to stop here. We're going to multiply by 100. So you have 100x equals negative 2.4, the repeating part. We want to get rid of the repeating part. So if x equals this, and we want to get rid of the repeating part. If we want to get rid of the repeating part, this becomes the part that we use to subtract. Okay? So now we're going to have to multiply by another 10 And when we multiply by another 10, we get 1000x equals negative 24.4 repeating. Okay, so this gets a little different here. So we're going to use this equation and this equation, not this one. Before we would just use this equation, but you have to get rid of the repeating part. So we're going to subtract 100x. Two negatives make a positive. 2.4 repeating. And where did I get that from? I got that from this one right here. So as you can see, the 0.4 part drops off. Okay, so now we have 900x equals negative 22. And so now we divide both sides by 900, divide both sides by 900, and x will be, reducing the fraction, 11 over 450. And if you divide that out, you will get 0.024 with the 4 repeating. So that was our final example. Why don't you try to do the problems, and I will see you at the end of the video for the recap. This is the part that repeats. This is the part that repeats. This is the part, only the 8 repeats, nothing else but the 8 repeats. So be careful with this one. Look at example 3 for how to do this one. Okay, so we have the repeating 87 as a fraction. So let x equals 0.87 repeating. We have to multiply this one by 100. And we get 87.87 repeating. We're going to subtract out the first equation, minus x. .87 repeating. So now you have 99x over 87. And so when we divide by 99, divide by 99, x equals, let's see, we can divide 3 out of here. Remember, simplify your fractions at all costs. We get 29 over 33. And that is our fraction. So 2 more. Okay. 216 is a fraction. So this is straightforward. The whole thing repeats. X is going to be 0.216. We got to multiply by 1,000. 216.216 repeating. So we subtract our X. So get rid of all of the repeating part. 999x equals 216. Divide both sides by 999. X will equal. So now we can reduce this fraction divided by 3 over 3. We get 72 over 333. Let's try another 3. That's 111. And we could have divided 216 by 9. We get 24. Does 111 divide by 3? Yes, it does. So you get 8 over 37. Ah, I forgot to show you that I divided by 3 over 3 again. So this reduces down to 8 over 37. And so I could have did 3, 6, 3, 9, 27. I could have divided both of them by 27. Yep. Okay. So I'm showing you how I even reduce, even if it's numbers that I don't recognize. Sometimes you can just divide by simple numbers and reduce these numbers down, these big numbers down into smaller numbers. So get some practice at doing that with big numbers. Just keep reducing them by 2s, 3s, and 4s. Okay, so let's look at problem 3. Now, this one is a little different, where the 8 is the only part that repeats. Okay, so what we are going to do is let x equals 0.048. That's the part that repeats. So now we have to multiply by 100, and I'll explain why in a second. Move the decimal point twice, you get 4.8 repeating, because we separate the part that repeats and the part that does not. The 4 does not, and the 8 does. We separated them by a decimal. And so now we need to multiply by 1,000. Well, why do we do that? So we multiply this one by 100, and then we multiply this one by 1,000. And so why do we do that? So we get 48.8 repeating. Now that we have the repeating on the right side of the decimal, we can work with these two equations right here. I'll put a box around it. So you take 1,000, x equals 48.8 repeating. You subtract 100, x equals 4.8 repeating. And as you can see, the repeating part drops off. You're left with 44 equals 900 x. We divide both sides by 900. And x will be, if we divide by 2 over 2, we get 22 over 450. And I left 2 even numbers, so I'm going to have to divide by 2 over 2 again. I get 11 over 225. 225 is not divisible by 11, so x equals 11 over 225. And what this means is that this repeating number, this fraction becomes a repeating number. And this is why repeating numbers are rational, because you can turn them into fractions. And so we did all of that to show you how we can turn numbers into fractions. So hope that makes sense. I I don't know, really math teachers don't really get the time to teach this one. We kind of accept it, but you can always, on your calculator, hit, if you have a TI 84 or 83, hit math, enter, enter. When you hit math, it's the button below the green button on the top left. It will bring up a menu, and number one, the first one says decimal two fraction, or it says a right arrow two fraction. So it'll automatically take a decimal and turn it into a fraction for you. So whenever you get repeating numbers, you can automatically turn them into fractions. But they will be the reduced numbers. So if you do your math and you get something different than what you see on your calculator screen, if you have a calculator, remember they reduce the fractions. So do not forget to reduce your fractions. And so that is the end for this video, and I will see you at the next video.